Hi everyone. Today we're going to take a look at a power series. Now, this has been the title of our notes the last few days, but we haven't actually discussed what a power series is. Now, before we get to that, let's take a look at this opener. Consider the following infinite geometric sum. So I'm going to zoom in on our series here. Okay, so remember, a series is a sum, right, of a sequence. So this sequence is a little bit interesting because this is our first time seeing a sequence that has an x in it, right, instead of just n in it, right, because that's our variable for the infinite sum, right, our series here we are dealing with. Okay, let's write out the first few terms and we should notice some interesting things right away. So when n is 0, x plus 1 to the 0 is just 1, so it goes away. We get a half. N is 1, we get x plus 1 to the first power over 2. N is 2, we get x plus 1 squared over 2. N is 3, we would get x plus 1 cubed over 2. N is 4, we get x plus 1 to the fourth over 2, etc., etc. Okay, so the reason this is geometric, right, if you look at the terms, is we're just multiplying the next term by another x plus 1, that quantity, right? Okay, so because this is geometric, that means it has a common ratio, right? So again, what are we multiplying to get from the n equals 1 to n equals 2 term, for example? We are multiplying just 1 x plus 1 to it, right? Okay, but here's the thing. Because we know this is geometric, right, and we know we have a formula for the sum of an infinite geometric series, but the thing, though, is that formula only works when the common ratio is between -1 and +1, right? So this r, which is again the quantity x plus 1, must be between -1 and +1 in order for this sum to exist, or a word we've been using to talk about sums having a value, right? It must convert in order for it to converge. Okay, so we can set up a little compound inequality, right? And now we can use this to solve for x, right? And so we call this answer the interval of convergence, right? So this sum, right, this series is only going to converge if this x is specifically between -2 and 0, right? That is the only way for this to work. Now, what does it converge to? Well, again, we have a formula for this, right? What is the sum of an infinite geometric series? It is a sub 1 over 1 minus r, again, given that r is between -1 and +1. Okay, so a sub 1 we already found, r we've already established, right? So now we just go ahead and simplify this. 1/2 over the 1's cancel. We get -x. And we can go ahead and rewrite this as -1 over 2x. But again, this is not true for all x's, right? Again, the only way that that series converges is when x is between -2 and 0. Okay, so there's lots of series like this. Let's take a look at another one in example 1. So this series is the sum of powers of x. So x to the n starting at n equals 0. Okay, so let's plug in some values, right? Our first term is 1. The next term is x to the first. And then we get x squared, x cubed, x to the fourth, x to the fifth, etc., etc. So what would this equal? Well, we know what a sub 1 is, right? And we know we're just multiplying by x every time, right? If I'm just increasing the power of n by 1 in this series, ding, 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 power series, right? We are just multiplying by x every time. So a sub 1 is 1, and then r in this geometric series must be s. And so we can go ahead and use our formula, again, from up here, which we know from back in the Algebra 2 days, right? A sub 1 over 1 minus r. Okay, So we get 1 over 1 minus x, but again, just like the last one, this only works when the common ratio is between -1 and +1, right? So I'll do the same thing here, right? If r must be between -1 and +1, well, r here is just x, and so that means x is between -1 and +1 in order for this to work. That's my interval of convergence, not International Olympic Committee, okay? Now, another thing we can do is we can kind of shorten this up, right? Instead of writing this out as a compound inequality, I can say the absolute value of r must be less than 1. And so again, for this series, r was x, so I can say the absolute value of x must be less than 1. And we get another measurement called the radius of convergence. Okay? So radius, think of the number line. Pardon me. If I'm -1 to 1, right? Think of the center of those two numbers on the number line. Well, that would be 0, right? 0 would be in the middle, right? And then 0 to -1 is a radius of 1 unit, or distance on the number line. 0 to +1, right? Again, think of it like a distance, right? That would be 1 unit as well. Okay, so two things that you can get asked to find very commonly: radius of convergence and interval of convergence. Okay, let's keep going. Group example 1. So we have an infinite series here, right, of powers of cosine. So cosine of x raised to the nth power. So if we plug in 0 to start, cosine of x to the 0, cosine of x to the first, cosine of x squared, right? So anything to the 0, pardon me, is 1, plus cosine of x, plus cosine squared, plus cosine cubed, plus dot, 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 dot. Okay, so we are starting with 1, and we are multiplying each successive term by cosine. So a sub 1 is 1, r is cosine of x. So what is the sum of this infinite geometric sequence? It is 1 over 1 minus our r value, right? A sub 1 is 1, r is cosine of x. So that would be the sum of all of these powers of cosine. Okay, but we are asked to determine the interval of convergence, and so we take it back to any geometric series, right? Absolute value of r must be less than 1, which means r must be between -1 and +1. Our r is cosine of x, so cosine must be between -1 and +1. So now it gets a little tricky, right? We have to think about unit circle, right? So let's think about, we can't have equal to's here, right, in order for this to work. So when does cosine equal 1? Well, that's at 0, 2 pi, right? And then anything coterminal to those. When does cosine equal -1? Pi, 3 pi, and any more coterminals of those, right? So what that means is that x, right, what x values work here is anything except, right, basically multiples of pi, okay? Because any multiple of pi, or sorry, any integer multiple of pi, I should say, right, is going to make cosine either equal to 1 or it's going to make it equal to -1. And remember, that's the range for cosine. Cosine is only ever between -1 and 1 inclusive, right? So we're going to exclude all of the ones that make it equal to the endpoints. Okay. Okay. Pardon me, one moment. Okay, let's take a look at B. So, we have a series here, 5 times the quantity x plus 4 over 3 to the nth power. What are some of the terms of this? So plug in n is 0, all of this goes away, we get just 5. Let n be 1, 5 times the parentheses to the first, 5 times the parentheses squared, etc., etc. So first term is 5. What are we multiplying by? Well, whatever is in the parentheses. Okay, so what's the sum? S sub infinity a sub 1 over 1 minus r. And now we just have to do a little bit of algebra to simplify. Let's get a common denominator in the bottom here, right? 3 minus, make sure you distribute the negative, negative x minus 1. Go ahead and multiply by the reciprocal. I also just took the negative from negative x minus 1, factored it out, just decided to write it with the 5 instead. I could have just written it with the 3 here, because at the end of the day, those get multiplied, and we get negative 15 over x plus 1. Now again, this is only the sum if r is between negative 1 and positive 1, right? So absolute value of r must be less than 1, okay? Now, for one thing I'm going to do here is I want to talk about the radius of convergence, okay? Now, my r was x plus 4 over 3. I can take dividing by 3 out of the absolute value, because dividing by 3 is not going to change, right, what is in the absolute value, right? Because dividing by 3, if a number is negative, it would stay negative. Even if I divided it by 3, same thing if it's positive. So if I take that 3 out, I can multiply it to the other side, and I get the absolute value of x plus 4 must be less than 3. That's my radius of convergence. And now, if I write that out as a compound inequality, so negative 3 less than x plus 4 less than 3, subtract the 4 on each side, I get negative 7 to negative 1 is my interval of convergence. And now there's one more thing I want to mention here that is going to come up, is this idea of centering, okay? Right? So if I go back to example 1, right, I kind of talked about this with the number line, right? The interval of convergence on example 1 was negative 1 to 1. Well, what's in the middle of that? It's x equals 0. That's where this series is centered, right? Well, this one, part B here, right? This one's kind of been shifted. It's x plus 4, right? So what number is between negative 7 and negative 1, right? Think about the number line. What's exactly in the middle of those, right? It is x equals negative 4, right? So this series is centered at negative 4 with a radius of 3. That's how I get this specific interval of convergence from negative 7 to negative 1. Okay, so let's talk about a power series. We have two kinds, okay? The first is centered at x equals 0, okay? So basically, every series kind of looks like this, right? It's just some constant times a power of x. Now, this one is not shifted. The center is at 0, so it's just x to a power, okay? So c sub n is just a constant, right? It can be anything. So like in these examples, right, it was, 5 times something. The cosine example didn't have a constant, but there could be some constant there. And we'll talk more about that in the next notes, how the constants get interesting, okay? But this is a power series, right? It's a geometric series, right, where the r value is some power of x. So x to the 0, x to the first, x squared, x cubed, right? We're multiplying by an x every time. If it's centered at x equals a, right, it just kind of looks like it has a shift. Think of graphing back in Algebra 2, right? You had your family of functions, and then you could shift it left or right. That's really the only difference here. Quantity x minus a, so the shift is x equals a. That's where it gets centered, okay? So what you're multiplying by is a x minus a to the first power every time. That's your common ratio, okay? And no matter which kind you have, these can converge potentially for all x values, or like the ones we've looked at so far, a specific interval, or just at one particular x value, right? The center, okay? So we'll kind of see some examples of all of these. Okay, let's take a look at example 2. Okay, example 2 says given 1 plus x squared plus x cubed plus dot 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 equals 1 over 1 minus x. Well, this is given, right? But actually we proved this, right? Let's go back to example 1 real quick. That was our sum. right? Using our formula, a sub 1 over 1 minus r. Okay, so yes, it's given, but we actually proved that. Okay, so that's not coming out of nowhere. Okay, so here's the thing. Given this, right, find a power series to represent 1 over 1 minus x squared. Okay, that's interesting. So if I think about these, 1 over 1 minus x is the same thing as 1 minus x to the negative first. 1 over 1 minus x squared is just 1 minus x to the negative second. Now, let's start thinking calculus, right? Really, the only difference is just the power. And what's happening with the power? I went from a negative 1 to a negative 2. How do I take a power and make it 1 less? I'll give you some time to think, and hopefully you're shouting it, right? It is, let's take our series, right? And let's take the derivative. Okay, so I've added a little bit of notation here, right? Okay, so this is what we proved in example 1. 1 plus x squared plus x cubed plus dot 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 equals 1 over 1 minus x. Again, this is coming from a sub 1 over 1 minus r, right? What this sum is, I'm going to call f of x, right? It is some function, right? This function is equal to this infinite sum. What I can do is I can take the derivative of this function, that is called f prime. Well, that is equal to this infinite sum, which means I can take the derivative of every one of these terms, right? And now, what's the derivative of 1 over 1 minus x? Well, if I do this correctly and apply the chain rule, I will get, hey, 1 over 1 minus x squared, right? So now, if I just look at the terms, right, so again, derivative of 1 is 0, derivative of x is 1, derivative of x squared is 2x, x cubed is 3x squared. The next term would be x to the fourth, 4x cubed, dot, 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 right? We would keep going, right? So how do I get this as my answer? 1 over 1 minus x squared. I took the derivative of 1 over 1 minus x, which means taking the derivative of all of the terms that add up to this, right? And so now I get a brand new series, right? And so how do I notate this? So I'm starting at 0. My next term is 1, 2, 3, right? So I can start n at 0, right? And so this is just n times x to the n minus 1, right? Because this, the one we started with, if we go back to example 1, was just x to the n. So again, what did I do to all of these terms? I just took their derivative. And so what am I writing in my sigma notation? Right? It's the power rule, right? That's all that is. That's crazy. Okay? But if you add up all these terms, right? It's the same thing, right? Take the derivative of the functions, right? Take the derivative of the things that add up to those functions. They're going to be equivalent, which is kind of crazy. Okay, we're going to go ahead and skip example 3, right? Let's go down to example 4, kind of the same idea, okay? Pardon me. Okay, so given f of x equals, so now, right, this function is going to be based on this series. So all of these terms, these infinitely many terms added up, negative 1 to the n, x to the 2n, right? And now we want to know what is the integral of little f of x, which is capital F of x in our fundamental theorem notation, okay, right? So we'll come back to the integral part in a second. Let's just talk about the terms, okay? So again, I want to take the integral of f of x, right? Which means I'm going to be taking the integral of all of the terms in this series. Well, let's write out some of these terms. What are these terms I'm going to take the integral of? If I plug in 0, right, I'm going to get negative 1 to the 0, x to the 0, right? That's just 1. Plug in 1, so that's a negative x to the 2n, so that's x squared. Plug in 2, so double negatives, that'll be positive x to the fourth, right? And so hopefully the more you see these, you'll pick up on patterns, right? We have alternating coefficients of positive and negative, and then we just have x squared, x to the fourth, x to the sixth, right? That's because of the x to the 2n in the formula, okay? Now, if I just think of this geometric series, right, a sub 1 is 1, and now, right, I'm multiplying by, from one term to the next, negative x squared. Okay? Now, again, I'm going to go ahead and simplify this. What am I actually trying to do here? I want the integral of this. I'm taking the antiderivative, right? So integral of 1 over 1 plus x squared. Now, here's the thing. Technically, there should be a dx here, right? But there isn't. But nevertheless, do we know the integral of 1 over 1 plus x squared? I'm hoping alarm bells are ringing, right? Because that is a top 20 integral, folks, right? And that is arctangent, right? Good old tangent inverse, okay? And so, based on what we just did here, if we took our series written out term by term, right? Let's take the antiderivative of all of those, right? Okay, what's the antiderivative of 1? X. Negative x squared. Negative 1/3 x cubed. Positive x to the fourth. It would be 1/5 x to the fifth, etc., 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 right? All of those terms are going to equal tangent inverse. This is crazy, right? Tangent inverse of x is equal to this infinite sum, which can be written in sigma notation, right? And so if we take our formula and we go, okay, cool, what's the antiderivative? X to the 2n, that's just going to be power rule, right? And then the negative 1 to the n, that's like a coefficient, right? That's just the alternating signs, so that part can stay. Okay? But based on this one, right, and the fact that, when we do the sum of an infinite geometric series, we happen to get something that's a top 20 integral, right, we can come up with a sum for arctangent of x, which is kind of crazy, okay? And so, let's go back to interval of convergence for a moment, okay? So, x to the 2n, right, for f of x, that's going to be r, right? Because we're just multiplying x squareds well, technically negative x squareds, but the absolute value gets rid of the negative, right? And so x squared has to be less than 1, the absolute value of that, right? So that's just going to be between negative 1 and 1, okay? And even for big f of x, right, we're just multiplying x squareds every time. Yes, the signs are alternating, but that doesn't affect our radius, right? And so, or our, excuse me, not radius, our common ratio, right? And so it doesn't affect our interval of convergence either. Okay? All right, so that's it for these notes, and I'll see you next time.